So let's consider a limits example. We want to evaluate the limit as x tends to 2 of 3. Well, there's no x in the actual function expression. Our function is f of x is equal to 3. And that will always be 3, and there's no problem with any values of x to be put into it. So that limit is just simply 3. With x cubed, we have no problems with any values being input. Any value of x can be put into x cubed, so x tends to 2 is going to give us 2 cubed, which is 8. So here we have the limit as x tends to 0 of x squared minus 7x over x. So that's the limit as x tends to 0 of x minus 7 divided by x. Now we know that we can't actually use 0 because we end up with 0 over 0, which is undefined. The function here we could write as x minus 7 provided that x is not equal to 0. If x is not 0, we can cancel the x's. And it's undefined if x is equal to 0. So if we tend x to 0 using this, we can see that the limit as x tends to 0 of x squared minus 7x divided by x is equal to negative 7. And then with this one, we have the limit as x tends to negative 5, and of course we can't use that because of the denominator here. So if we factorize the top, so x tends to negative 5, we've got x minus 5, x plus 5, all over x plus 5. So we can see we can't use negative 5 because we end up with 0 over 0. What we could say here is that f of x is x plus 5, sorry, we're going to cancel x minus 5, so it'll be x minus 5 in the case where x is not equal to negative 5. So if x is not equal to negative 5, this is not 0, this is not 0, and we can cancel them. And it's undefined in the case where x is equal to negative 5. So if we now consider the limit as x tends to negative 5 of x squared minus 25 over x plus 5, well, we're using this function. If we tend x to negative 5, this becomes negative 10.